So I miss Savita. Thanks for telling about Savita as well. She couldn't come today because of personal priorities, as well as there was an equivalent important activity in-house, like at office as well. So with that, let's start. So for the rest of the few minutes, I'll be talking about cryptographic agility. I think I have captured most of the things like cryptographic agility. So the earlier recorded session by Tony was very informative. It is kind of, it's at a nice base work. I don't know how many of you attentively paid attention to the data points. Paid attention to that. So there were these timelines, if you remember, Australian government and UK, they have given timelines of 2028, 2035 for replacing RSA and ECC algorithms in the current application. So it's 2025, right? Why they have set such a long timeline? What's the difficulty we have? So today we don't have quantum computers, like cryptographically ready quantum computers, which are actively being worked upon. And then we also know it's very evident how fast AI can create applications and how fast it can induce threats in the application. So with all these things, they are still in the initial stages, so they are seen as threats. That's why the regulations have kept the timelines as 2025 or 2038 like that. It's like it can come anytime. That's the state we are in. So what's that that's stopping us? So that's why we need to be little fast. So in our terms, we always call, like if things have to happen fast, we call it as cryptographic agility. I'm just telling these things in very simple terms, not going by the NIST standard definitions. I have given the references as well. So agility is basically to act fast to these cryptographic threats, especially the quantum cryptographic threats that are incoming. So how do we act fast? Only if we have complete knowledge on anything. If we are fully informed of something, then only we can act fast. That's the whole idea of this talk. So like how do we create an inventory? So what's the purpose of an inventory? What role does an inventory play to make this environment or ecosystem more agile? Following that, how do we create one such inventory? It's not just, there are tools coming up, like now we saw so many working groups, so many tools that are being actively worked upon. So we have picked one tool by IBM, which was originally done by IBM, and it was open sourced and adopted by an alliance, PQCA, who are dedicatedly working in this area. So we will go through that tool in action and see how we are able to generate an inventory. So that's the agenda. So let's just start. So it's reiterating the same concept like what was captured or what was discussed during the earlier session, cryptographic agility by key factor. So it's the ability to replace and adopt cryptographic algorithms without disrupting running systems. So how like dreamy, right, that statement. How if I ask you, like if you are doing an application, like if you're owning an application, so today if the security officer tells, okay, go replace all RSA to something else, like how will you feel? Is that possible? Will it be possible without disrupting your running application? It's like a dream, but that's the final state that is expected. So when we say ourselves we are cryptographically agile, it's not that just an isolated function from a security team, or like as an application, like as a software industry, how cryptographic agile our applications are. It's not about the process, it's more about what we ship as code, like how agile is our code, how agile is our application. So can we do this? How to come to that stage? Like that's the final state we want to be. So to reach to that state, what do we do? So these are the pushes, like what pushes us to come to that state is CRQC, basically refers to cryptographically ready quantum computers. We are not yet full into that. So these computers are very specialized in running the quantum algorithms, Shors and Grovers, like enough information is there, we can look out like why they are very specific, why should we talk about Shor's algorithm in a security related conference. So they can, it's all like, everything is about encryption, decryption. So what you do cryptographically in cybersecurity is about encrypting your data so that unwanted, unintended people cannot access your data. Now, when you are encrypting, it's all mostly mathematical or some secret code. So if we have a capable algorithm which can crack that, then we are in stake. we are in a we are at risk, right? So that's the state. So cryptographically relevant quantum computers are designed to run these algorithms which can create brute force attacks and crack these existing algorithms. So they are seen as threats, and that's the push for standards like NIST and CRA to come up with all these mandates, like how to migrate and all. So with that, when we say cryptographic agility, it's not someone else doing, coming up with a standard process for the entire organization, instructing the team to follow all these things. It's not that. In our day job, these are the simple steps that we can do. So when we are developing something, do not hard code your apps with algorithms. Like, avoid hard coding any single algorithm. Say you might have, most of our container images are short. Come up with a SHA-256 digest, which we will be aware. So if there is a need that we'll have to migrate to SHA-512 or some other version, like how easy will it be? Because the tooling is mostly, if I take Docker CLI, will it be able to withstand that change today? So we should come up, like when we start designing our tools, like come up with solutions that do not allow hard coding, and it should also allow algorithm switching. Now, that was another aspect that was captured in the key factor discussion, interoperability. So you have to abstract away your logic in your application, abstract the things, and possibly make it as API so that these algorithms, these cryptographic algorithm calls are all not existing within the application. So it's making it more interoperable. And then the focus of this session is locate where, like where is what are all the different cryptographic assets, and where in your entire source code or running environment, where are these located, so that it will be easy for us to swap. So how do you locate that? That's by creating a good inventory of what that asset is, the properties of the asset, and where it is being used. It's simple. So like what it is, where it is used, and how fast can we replace it. So that's the 3 core concepts. Like as first point is more about design principle. Second is in creating an interoperable design, doing interoperable design. And third is working out to create inventory. So with this, what we emphasize is, again, to achieve cryptographic agility, which is a mandate for us now, there are multiple aspects we'll have to take into consideration, and one among this is inventory. Now, why did I have the term actionable real-time inventory? So when we create an inventory, it should not be a dump of everything that I capture from everywhere. It should be a machine-readable content. Only then we can do automation on top of it. So that's the idea. So it should be a well-defined. That's the reason why we have specs, right? So open API specs. So you have a well-defined structure so that any tooling that is built on top of this data is easy to build. You have a standard. So that's the idea. So you have an actionable real-time inventory of for cryptographic agility. So this is a kind of give a big picture of what a final solution could be. Imagine you have a centralized cryptographic inventory which is properly populated from all areas. Like the outline here, section outline here is a list of all possible sources. It could be from your software, hardware. We are not at that stage yet, but this is all there are a lot of working groups and tools in progress. We can actively contribute and build this final state. So the possible systems that could be tracked for cryptographic assets are source code repositories, tools, network traffic analysis. So we can figure out, with our own innovative approach, we can figure out how to capture all these and then store them, create an inventory of this. And based on that inventory, we can build a completely automated compliance engine. Like looking at that asset inventory, we can query, okay, so which part of my organization or which domain of my applications are in stake. So that level of automation compliance report can be made, and the best part is making it completely an automated agile engine. Like we can replace, like we can find out and swap. So if I had already this state in my ecosystem right now, so when the industry announces, okay, replace RSA and come with some XSA, then I would have immediately done the needful. At least I can point out where it is. Now it is, you tell the application team, you first announce it as a standard, and then the teams take action, and then they come with their own timelines of, okay, with this is possible, this needs an enhancement. So many things are going on. So in order to, come out of all these things and become completely agile, we need a agile cryptography, this inventory. So I think please go through that video. from key factor, that was more about interoperability, and this is more about creating an inventory. Now we have talked enough of inventory and all those stuff. Now let's come to the reality, like what exactly we want to inventory. So we want to inventory the cryptographic assets. What are cryptographic assets? They are the ones which are used to secure our data, which are at rest, which are in use, and which are in transit. So what is it we are doing with all this cryptography? Any application, end of the day, handles some amount of business data. So that has sensitive data. So that has to be secured from adversarial, it should not get into the hands of irrelevant people. So how do we do that? So that's where we use different encryption, decryption mechanism, and then we also ensure trust of who passed this message through proper signing and certificate. So basically these assets are the ones that enable the secure, protection of the sensitive data by multiple means, like encryption, decryption, signing, and communication. So most of these are the list of assets that are captured right now. Now, a huge amount of work has been done by Cyclone D OWASP community, and they have published, along with this extended version of SBOM, they have published this CBOM guide. So, as per the current state, these are the different asset categories that the CBOM structure supports. So, okay, so this is just a sample CBOM. Hope this is visible. So if you see, it's a JSON, if in the components, in the JSON, imagine that we will see it in action in a demo now. Imagine that the output of analysis of that particular tool is a JSON, and within that JSON, it will contain the list of all cryptographic assets that is used in a given source code, for example. That's what we will see now. So, so this cryptographic asset, if you see the fields, it has the evidence of which line of code is using this asset, what is the type of this asset, whether it is an algorithm. So in the previous slide we saw, it will categorize whether it is a protocol or key or password, whatever, and then it will tell what is the asset type, and then it will also give us the information of where this is occurring, and then additional properties, like what are the additional properties, like what's the identifier, whether it is 1024 or 2048, based on the class of encryption we have selected. Accordingly, it will give us all the details. Now, like this, imagine if all this, if we are able to create a CBOM or create a detailed information about all these things and store it in an inventory, it becomes very handy for us to quickly take actions. So this is just a closer look of it. So the CBOM on a high level has categorizes algorithms which are used for encryption, decryption, which all the cryptographic activities, or it could have a certificate definition and its properties, or the protocol and its properties. So these are the four broad categories that the Cyclone DX spec as of now allows us to capture the CBOMs. Okay, so with this, I'll pass. So we have seen all the theoretical concepts, like what's the need for agility, the role of inventory, and how an good inventory can be created with a well-structured cryptographic bill of materials, that is CBOM. Now, how do we generate that CBOM? Do you manually create, or how do we do? Are there tool sets? Yes, there are a few tool sets. I remember in the key factor content as well, there was a pointer to key factor command CLI, I guess. That's also, I'm not too sure about the level of open source, but we do have an open source tool called CBOM Kit, which was originally, as I said earlier, done by IBM, but it is now open sourced and actively taken care by PQCA. So we can contribute. So this is the scanner code. If you are interested, you can also contribute. So now, just looking into the kit, very high level, what is kit and why, why we personally like this kit. When we started evaluating the tools, there are few other tools also being evaluated within the organization. But what this CBOM kit, what are the components of this CBOM kit is, it has a scanner which connects to the source code and generates the CBOM scanner module. And after generating the content, it also allows us to have a configurable compliance engine. So your organization will have your own policies. So against those policies, this CBOM can be evaluated. So that is the compliance check module. So we have the generator module, scanner module, and then from the generated CBOM, based on your organization's policies, you can do a compliance check. It is stored for audit purpose. Like at a given point in time, what were the algorithms that were being used? As time moves on, something might have changed. So at that point, what has happened, if you want to know, we can use this database. And then obviously for user friendliness, like this JSON is little difficult to always track. So we have a UI component in the CBOM kit which helps us to give a very nice visualization of what are the cryptographic properties. So these are the 4 core components. Okay, so this is the demo that we will see now. So what I'll do is we have, so this demo will be primarily focusing on creating an inventory of cryptographic assets from source code repository. Very simple use case. So we have a source code repository which uses a bunch of cryptographic algorithms. So we will trigger a GitHub workflow whenever we come. So this can be, as we know, the CI workflow can be configured the way we want. For demo purpose, I have kept it as push. It could be on merge, or it could be scheduled on a daily basis or weekly basis, depending upon what we need. So we will do on push. So a workflow will be triggered. The workflow will submit a request to scan to the CBOM kit, and then after scanning, it will query the DB and do a compliance check, and finally state that, okay, whatever code changes made are in the current form, whether it is okay or not. So that's what we will see it in action now. Okay. So this is a basic cryptographic code base, very simple code base, which makes use of a bunch of cryptographic algorithms. So I have the CBOM kit running in my local, okay? And then since it is in my local, you can try this deploying in a kind cluster. So it's in my local. So if I have to connect to the GitHub repository, I have a proxy running. So this will allow the GitHub repo to pass the push event and allow the API request to be redirected to this. And then this is the database, like the CBOM kit database layer. Right now, this doesn't have any CBOMs. Let me just do a quick thing. This doesn't have, yeah. So while it runs, it's an empty DB as of now. Okay. So parallelly, I'll also show you the UI part of it. So this is the UI module. Right now, if you see, the connection to the server was successful, but the CBOM database is empty. So now it's very like a fresh installation. So what I'll do is I'll simply do a push to this repository. So I'll do it from here. I'm just doing a direct commit, not doing any. So we have committed. Now if you see, it should have triggered a workflow. Yeah, as you can see, this has triggered a workflow. CBOM scan in progress. Okay, so let's go to the details of the workflow. So it has triggered a CBOM scan. Yeah, so if you see what it has triggered, so for this repo and for this particular branch, specifically for this commit, whatever commit I have made, it has made a scanned request. So now, based on the repository size, the scanning can take some time. There is a lot of scope for improvement in this tool. The scanning can take some time, but it has successfully, so I've just kept a wait time. And then based on what was scanned, it was fed into the database, and the output was verified again. So if I expand this, I'm doing a compliance check again. It's again an API call. So the good thing about the kit is it's all API. So you don't need to integrate into your CI workflow, and you have multiple. It's centralized. It's easily centralized. You have APIs already. So this is called this compliance check API. And then this is the output. this output is also a structured JSON which will classify for each asset that was generated in the CBOM, what's the status, and then finally it will say whether it is compliant or not. So now if I go back to the UI, and so you can see whatever the scan that was made, that is reflected here. So this is the commit. So it has identified 32 cryptographic assets, and this is a easy to view visualization part, and like anyone can quickly see this. They don't need to evaluate the JSON, everything. So this gives the list of all primitives and what are the, basically that has an RSA, and yeah, it has an RSA and hashing, so for signing and hashing, so that is what it is listing at primitives, and what are the different functions that were called, and these are different assets. So this is just nice to have visualization, not a mandatory part. All we are interested is in the CI workflow, like whenever we do something in the code, momentarily we will get to know whether that particular repo has any algorithms or crypto assets which are not PQC safe. So as I said, this policy compliance check is configurable. Right now it is configured only for quantum safe. Whatever our organization needs, we can configure, classify, and then we can make the call accordingly. So this is it. So now, I don't know if it will. So yeah, let me just, maybe I'm not too sure, like, yeah, database alone I'm not able to connect, but the UI and the workflow has gone through successfully. So this is it. So, this is it all about the tool and CBOMs. Any questions? Any questions?
So I have one question that currently the industry is moving towards hybrid approach, right? Where neither the traditional is already proved broken, but even we can't trust PQC. So does this tool consider that as well, or even the crypto agility as well? Because now earlier what RSA was creating the certificate, now you have to wrap that certificate with another MLDSA or SLS DSA from the PQC. So
okay, so this toolkit is little, it doesn't need to bother whether it is hybrid mode, what the organization is adopting. They can adopt anything. This is to inventory, what is being used in the current situation. It's just as JSON, the names will change. So if you remember the properties, so this one, so even if it is a new algorithm, it will fit into the algorithm category. Broadly, we are using algorithms, certificates, and protocols. Beyond this, if there is something that comes up, probably this will be extended. But in its current form, it is suffice to address all the, both hybrid as well as, I don't think anyone is migrating completely to PQC as of now. Mostly it will be quantum safe versions of existing algorithms or the new algorithms only. So it should be, it will suffice. But this needs a lot of, as I said, there are a lot of opportunities for this tool to be improved. There are also other tools upcoming which can be evaluated if we are planning to create this inventory. So the limitations are, right now it supports only Java and Python code base assessment. So other language supports are not yet supported. And a lot of things have to be stabilized in this code base itself. So to answer your question, yes, it addresses both the states, like current state and hybrid state.
We have time for one last question.
Hi, this is Madan from IBM.
Yeah.
I'm pretty much aware of this Cyclone DX tool. So basically, like when I started using it, it really works on the code base, not really works in the production environments. That's a struggle we have actually, because we have big customers like JPMC, Bosch are trying to ask, how do you migrate to the quantum safe systems? Because 2030 onwards, you cannot run the system, some environments actually speaking. So my first question is, can this work still on a production environment where I have binaries, libraries and all? I hope it's not, but if you have any idea.
No, the image part, we wanted to test it, but actually we didn't got it to the image. But what we also are assessing is how can we use OpenGrip parallelly? I do get your point. That is the main. So we also have customers who are asking for this because Red Hat is also shipping solutions. So they also have to give this. So we are assessing a few other solutions parallelly, especially for the runtime issue only.
I have another question, but I will take you offline.
Sure. Yeah, thank you.
Thanks so much, Anitha.
Thank you.